Hey guys, welcome to my YouTube channel. So in this lecture we are going to mainly focus on the problems. So this is one of the questions that asked in GATE and IES. So this will give you very good understanding about the how to solve and how to tackle the problems which are asked in GATEs. So this is straightforward question. There is no internal tricks or nothing, but just a conceptual formula knowing will be very good for you guys to answer this question. So let's get into the question. So the dependence of drift velocity of electron on an electric field in a semiconductor is shown below. The semiconductor has uniform electron concentration of n into 10 power 16 and bias of 5 volt across 1 micrometer region, resulting current density in the region K. So this is a linear region is dash. So this is the question that I asked. So let's try to solve it. So pause the video and try to answer it. If you guys are able to get the answer, please post in the comment section and cross verify your knowledge. So let's start. So they're asking about the J net, the current density. So we can directly write a formula of J net. This is N. Why I am mentioning N is that they given a clue that is an electron. So that is N. So J N drift plus J N diffusion are the two terms that will contribute. Here in the question they given one super hint that it is uniform electron concentration. So from here we can came to see that this term will be tends to 0 because this will not be there as it is uniform concentration or uniformly doped. So there won't be any diffusion of electrons. So let's make that 0. So then we know the formula that it is equal to NQ mu N E. From the question we able to get all the values except the mobility. This is the constant value that is not given here. So but another one hint that given in the question is the drift velocity. So what we can make use of it is that we know the Vd which is equal to mu N E, right? So we can replace this formula here. So this is NQ Vd is a drift velocity. So drift velocity is the term that we need to identify in this region. It is a linear of region K, right? So we may not know which drift velocity we have to do because this is dependent on some parameter. So here then another information that given, right? 5 volt and 1 micrometer. So from this let's find out the E value. So E value will be 5 divided by 1 micrometer, right? So if we cancel it, then we will be able to get 10 power 4 V divided by centimeter. Let's make it centimeter as the unit here. So we will be able to get it. So let's substitute here and let's find out. But before finding that, we need to find the slope in the region L, region K. Because in this region only we need to find the current density, right? So from this region, let's find out the Vd and then substitute the E value there. So let's find the slope of Vd versus E. So if we find out the slope which will be equal to, let's take the upper value 10 power 7 minus 0, 5 into 5 power 5 minus 0. So if we solve that, then that will be 10 power 7 minus 0, then that will be 5 into 10 power 5 minus 0. So if we cancel it, we will be able to get the formula that is equal to 20. So 20 is the value that we will be getting here. Okay. So we need to find, this is a linear slope region, right? So Vd which will be equal to the slope value into x-axis. So that is equal to E. Let's substitute that is E here. So if we substitute that here, 20 into 5 into 10 power 4. So this will be the value that we will be getting. So once we solve this, we are able to get the 20 into 5 is 100. So that will be 10 power 6. So 10 power 6 is the value here, which is centimeter divided by seconds. So let's substitute this here. So J net which will be equal to N, that in the question itself they are given, that is 10 power 16 into 1.6 into 10 power minus 19 into 10 power 6. So if we solve this, 22 minus 19 will be 10 power 3. So 1.6 into 10 power 3 A divided by centimeter square. So this is the answer that we will be getting. I hope this is well understood for you guys. So if you guys have any doubt, please post in the comment section. So these kind of problem solving skill that is very important for you guys in order to solve either GATE or any kind of competition exam. Here the indirect trick that given is this is an uniform electron concentration. So from that we have to understand the diffusion charges will not be there, so that the Jn diffusion will be equal to 0. And then Vd is the hidden parameter that they are given. So we have to use the slope formula, the simple mathematics, and we have to apply the electric field from the hidden data that also given as a bias and length of the semiconductor. So if you substitute it, we will be able to get this answer. So if you guys able to understand it, please post in the comment section, and if there is any doubt, please post that also in the comment section. So like, share and subscribe the channel. Stay tuned for the next lectures. Like these kind of questions I will be making plenty, so that you guys will be able to get a good understanding of how the practically, like if you guys able to solve it, then only you guys able to understand more things. So this kind of understanding I will be contributing more in this series of semiconductor lectures. So please follow and subscribe the channels. Thank you.